Okay, welcome everyone. So today I'll be discussing some problems related to definite integral. So the problems are based on mostly lecture notes or lecture videos of week 9, and this is the eighth week of this problem solving session. So I think let's start with the first problem. Okay, so this is our first problem. So as I told you, the problem will be based on definite integral. So these problems will depend on the definition of definite integral. How do we are defining these integrals? You can see that in this question. Okay, here there is equality. Okay, so you can see that you have to find some limit in this case. Okay, so what is this limit? And this limit we will find using the definite integral. Okay, so this comes from the from the definition of definite integral. So how do we define integral of a function? Let me recall this definition once. So let's say if you have function bounded function on a closed and bounded interval ab. Okay, so your interval is bounded, a and b are finite real numbers, and your function is also bounded. Okay, and now we want to define the integral of this function from a to b. We write it like this. So what is an integral? This is basically the gives the area under the curve or the graph of the function. Let's say this we assume that it looks like this, and this is your point x equal to a, and at this point this is your x equal to b, and the integral gives the area bounded by the graph of the curve above x-axis. Okay, so this you can assume that y-axis and these are x-axis. Okay, so and now how do we find the area under this curve? So we uh, because we want to find this area, we want to we what we do, we can approximate this area using the area of rectangles, right? Because we know area of rectangles. So what is the area of rectangle? So if we have this rectangle, let's say, and it has some length and breadth. Okay, so the area is just length times this b. So let's not write this b. Okay, let's assume that this is length and the height. Okay, and the area is length times the height. Okay, so there can be a lot of approximation of this area under the curve. So what we can do, we can take this rectangle also, right? One of the possible rectangle, this is where the height is just f of a, right? So this point is f of a, and the length is the whole length of the interval. This is the length b minus a. This one can take. So the area can be approximately f of a times b minus a, or we can choose another interval or another point, height, length. Okay, so if we choose this point b, then this height is just f of b, right? And then your area of the rectangle is everything inside below this line, which is just f of b times b minus a, because the length of the interval is still b minus a, right? But now you can see that the error okay, so this approximate area, this contains a lot of error from the actual area, right? This is quite less because we are not counting this part in our computation approximation. And in the second case, we are measuring too much. Okay, so this part we are also measuring, which is not below the curve. Okay, so this is not actual area, so our area lies between this these two value. Okay, so now what we can do to better approximate this what do you call area? So we can further reduce the length of these intervals, right? We can take, let's say, some point c in between, and then there is a point on the graph which we call f of c, which is height is f of c. And then you can divide everything in two rectangles. Okay, you can take this rectangle and this rectangle, right? So now we have chosen a point between A and B, and now our area, which is approximate area, is the sum of these two rectangles. Okay, so we are okay. So we have these two intervals. One is A to C, and then one is C to B. And in each of these interval, we'll choose some arbitrary points. Let's call it C1 and C2, so that we can have taken height. Okay, so C1 has this much height, and then C2 has this much height, right? So we have these two rectangles. Okay, so in this case, what is our area? Okay, so from the second case, it is f of c1 times the length of the interval. So this time the length of the interval is just c minus a, right? Because we have taken a point in between, and then we are adding area of these two rectangles. In the second one, we are choosing height to be f of c2. Okay, so this represents the height of the rectangle, and then b minus c is the length of the interval. So this is the area, which is the sum of two rectangles. Now you can see that this we believe that this sum is a better approximation of our actual area, right? Because it just includes some part of the area under the curve, and that reduces the part which was outside the graph, right? Before the outside a lot of part was there, but now some part from the outside came inside the interval, right? We have counted more, we have measured more, which was below the curve, and we have measured less, which was above the curve, right? So our error must decrease in this way. Okay, now what we can do, again we can divide the whole interval in again a lot of parts. Can choose, let's say, these four interval x a to c1, then c1 to c, then c to c2, then c2 to b. Now there are four intervals. Then again you can choose some arbitrary point in between d1, d2, d3, d4, and then you can form these rectangles. Now there will be four rectangles, and like this you can increase number of rectangles, right? So in general, how do we write that? We say that we will take a partition of our interval, right? Here you have x equal to a, then you have x equal to b, and what we do, we will divide our whole interval into lot of parts. Let's call it x1, x2, x3, like this up to xn minus 1, and this endpoint will write at xn, and the first point, let's call it x0. Okay, so this is a partition of our interval. So what is a partition? Some points x1, x2, xn minus 1, and then xn equal to b. Okay, so this is a partition of our interval, and inside each interval, let's call this interval some. Okay, so ith interval we are denoting like this. So what is our ith interval? This is xi minus 1 to xi, and in this interval we'll choose some arbitrary point ci. Okay, so this is called c1, c2, c3, and like this cn. Okay, and now what do we want to do? We want to approximate the area, right? So notice that this f of ci is the height of a rectangle. Okay, let's assume that here you have ci, so there is some curve going like this, and f of ci is this length. This is our f of ci, this length. Okay, and we have our interval, which is xi minus 1 to xi. Okay, so if you form this product, which is f of ci into the length of the interval, that means you are computing the area of the rectangle, this rectangle. Okay, and like this you will add area of all the rectangles. So this we write as xi minus 1, and you add this everything up to I equal to 0 to, or either 1 to n. Okay, so this we will call it a Riemann sum with respect to partition. Okay, Riemann sum, and we denote it like this: s of the function f with and the partition p, and then our choices of this sets, right? We are making some choices of ci in the these pieces of the intervals. Let's call the set c. Okay, so what is c? C is this these choices of points inside the subintervals cn, and this Riemann sum corresponding to this partition and the choice set is denoted like this. Okay, now okay, so now our idea is that this Riemann sum is a must be a good approximation of our area of the curve under the area under the curve above the x-axis. But there can be several Riemann sum, because you have a lot of freedom in choosing the partition of your interval and then the choice set for a fixed partition. So there is a lot of freedom. So there can be several Riemann sum like this. So what do we want? We want that if okay, so we define this norm of a partition. So how do we define this norm? This is the maximum length of any subinterval, right? So there are a lot of subintervals in our partition, which we would denoted ai, and the length of this subinterval was xi minus 1. So this was the length of the subinterval, and now we want to take the maximum length. Okay, so this subinterval may not be of equal length. So some subinterval may be larger, some may be smaller. So this I going from 1 to n. Okay, so you take the max in this way, and that we call it the norm of the partition. And now we require that if the limit of this Riemann sum respect to the partition P and the choice set C, if this limit exists as the norm of partition goes to 0, then the limiting value, let's call that the limit is equal to L. So suppose that the limit exists and it is equal to L, that's right, capital L. Then we say that L, this limit is the integral of our function of f from a to b. Okay, and the limit we denote it like this. The limit is the integral, we denote it like a to b of f of x dx. Okay, so this is our limit. So basically the limit of this Riemann sum, which we have written like this, f of ci for this choice set involved, then the length of interval, which is xi minus 1 corresponding to the partition, and then we are taking limit when the norm of our partition or the length of our maximum interval goes to 0. This limit is basically this integral of f between a to b. Okay, so if this limit exists, then this is the integral and the function is said to be integrable. Okay, so now you can see that in the question you have to find this limit, right? And also the partition is also given, so you have a partition from 2 to 7, right? Okay, so the partition is given of this interval 2 to 7. Okay, a closed and bounded interval, and your x naught is 2, then you have x1, and between okay, so between x naught and x1 we have a c naught or c1, so that forms a choice set x1 c2, and like this xn minus 1 cn and xn, which is 7. Okay, so this partition is given, and then there is a limit is also given, right? So what was the limit? It is 36 times ck cube minus 12 times ck into xk minus 1, where k runs from 1 to n, right? Okay, and then you have to find this limit when the maximum, which we have already defined, the maximum length of your subintervals of the partition, that goes to 0. So at that case, you have to find this limit, right? Now we have already seen that this is a Riemann sum for some function. Okay, so what function is that? That we have to find out, right? You have seen that this is just the length of each subinterval. Okay, so these are f of ci's, right? So what? So from here we can guess that fx must be 36x cube minus 12 times x, right? So this is our fx, which we can also write if you take 12x common. So we can write it 3x square minus 1. Okay, so that means now you can see that this is a continuous function, and continuous functions are always integrable. Okay, so f is a bounded, so it is also bounded function, and continuous function on the interval 2 comma 7, and therefore this function is integrable, right? Okay, so now because the function is integrable, that means this limit must go to the integral of the function between 2 to 7 of fx dx. Okay, so this is our limit. The integral is the limit is basically the integral of the function between 2 to 7. Okay, so for finding this limit, you have to calculate this integral from 2 to 7, 12 times x, then 3x square minus 1 dx. Okay, now how do we calculate this limit, this integral? We can substitute, let's take this some t, and we are making a substitution. Then 6x dx must be dt, and this integral can be written like this. So it is 2 times 6x. Okay, so you can see that this 12x times dx, this will become 2 times dt, right? And then 3x square minus 1 is just t, so this is 2t dt. And now when x is equal to 2, so we have to also find the limits. Okay, so when x is 2, what is t? It's 11. When x is 7, but t is 3 into 7 square minus 1. So what is that? Okay, say 49 times 3 must be 147 minus 1. So 146. Okay. So this limit just become from 7 to 146. And this integral we have to calculate. Now you know that the derivative of t square is 2t. So this limit is calculated like this from 7 to 146. Okay, so note that we are using all this fundamental theorem of integral calculus, right? Because we know that if you take this function gx to be x square, now then we know that the derivative of gx is 2 times x, right? Therefore, if you want to integrate the derivative, because they are reverse process of each other, okay, from a to b, you must get gb minus g of a. This is the fundamental theorem of calculus. Okay, so this is second fundamental theorem of calculus. Okay, so that's why you have 146 square minus 7 square, right? This we can write as 146 plus 7 into 146 minus 7, which is equal to 153 times 139. I think there is some mistake. It was 11. So this was 11 square, 11. So 146 plus 11, 146 minus 11. So we have 157 into 135. So 157 into 135. The second option is correct here. So are there any questions?
Yes, I have a question, but off the topic.
What is the question?
Question is this year the assignment questions are like this is MCQ type, right? Now it
Yes.
would be or pen and paper examination. It would be just descriptive or display like same as.
I am not able to listen you. Can you repeat again?
This assignment questions are MCQ type, right? Choiceable.
Yes. Yes.
What will be our pen and paper question papers? Will those be the descriptive or the same as assignment paper?
Oh, actually, I don't know about that. Maybe they will be same MCQ type.
Okay, sir. Thank you.
I don't know. Okay. Okay. So let's move to the next problem. Again, here there is equality. Okay. So again, in this question, we have to find this limit. So now you can see that this is again a Riemann sum where there is a partition is given. So you can see the partition of your interval. So what is the interval here? Interval is minus pi by 4 to pi by 4. This interval is here and a partition is given and the choice set also given, these values of C. And then you have this particular sum and then it says that find the limit when the norm of this partition goes to 0. Okay, so this is our partition P, and you can see that this part is just the length of intervals, right? The length of our subintervals. Therefore, in the Riemann sum, this must be the part where we have f of ck. So this must be f of ck. Okay. So this gives the idea that the function involved here in this Riemann sum must be the cos x minus sin x by 2. Okay. So therefore, this sum just becomes the integral because now you can see that this function is just continuous and bounded, right? So f is bounded and continuous on this interval minus pi by 4 to pi by 4, and therefore f must be integrable. So integrable means that this limit must exist. This limit must be a finite real number, and that limit is actually the integral of our function from minus pi by 4 to pi by 4. Okay. So because the function is integrable, the limit must exist, and the limit is the integral. So now we can find the limit using integral, right? So this was we have to find cos ck minus sin ck by 2 into xk minus xk minus 1, where the norm of our partition goes to 0. This limit we want to find, and we have seen that this limit is just minus pi by 4 to pi by 4 integral of the function fx. Okay, and what is the function? This function was cos x minus sin x by 2. Okay, now we already know an antiderivative of this function, right? So antiderivative means if you differentiate the function, then you get the original function, right? Okay, so what is that? We have this antiderivative, right? Now you can see that if you differentiate this capital F, then you will have cos x minus sine of x by 2, and you apply the chain rule, then this 2 will cancel with half, which is exactly f of x. Okay, and therefore if you want to calculate the integral from minus pi by 4 to pi by 4 of this function fx dx, that is you want to calculate this integral, right? So here you can see that we have a derivative of capital F, and now from the first or if, from the fundamental theorem of integral calculus, this must be just f of pi by 4 minus capital F of minus pi by 4. Okay, so this is the limit, and now we can just calculate this limit. So what is that? F of pi by 4 means we have sine of pi by 4. So what is sine of pi by 4? Must be 1 over root 2, and then plus 2 times cos of pi by 8, right? And then minus, we have f of minus pi by 4. So if you take f of minus pi by 4, then you'll again have sine of minus pi by 4. Sine of minus pi by 4 is just minus of sine pi by 4, which is again 1 over root 2, because sine is a odd function. But because cosine is a even function, so here you will have again cos of pi by 8. So these two will cancel with each other, and you have final answer to be root 2. Right? So root 2 is the final answer. So any questions here?
No, that's all.
Okay. So let's move to the next problem. So all these problems are similar in nature. Okay, so again you have to find a limit, but now you can see that in this limit we don't see any partition, right? So there is no partition of interval. So actually there is, but it doesn't look very explicit, right? So how do we find this limit? This looks like a sum of the series, right? This is just a sum of the series. You can see that you can write this series as from n equal to 0 to infinity. Okay, so okay, let's not write like that. So basically I want you to say that this integral are also summation or infinite series, right? Series are just the discrete form of summation. Integrals are the continuous form of summation, right? So in the series you have a infinite summation, but there are some discrete values, discrete numbers which you are adding. You are adding just countably many numbers of a sequence. But in integral you are adding numbers which comes from a continuous interval, right? You are adding numbers from the whole interval a comma b. So it's a continuous summation, and series is just a discrete summation. So sometimes we can find a sum of series also using the integrals, but this is not that case. But we have to find this limit, which is 1 over n cube summation from k equal to 1 to n k times k square plus n square. Okay, so for finding some this limit, what we do, we try to write this sum so that it looks like a Riemann sum, right? For some partisans. So let's see what it can be. So just divide the whole thing by this n cube, take n cube inside, and then you can write one factor of n here, and then another factor you can take inside the square root. Okay, so we will write one more term here, 1 by n, and then take the third factor inside. So if it goes inside, then you have to divide by n square, right? So when you divide by n square, you will just have 1 plus k over n whole square. So this is you have now. You have to find the limit of this sum. Now consider the interval. So which interval are we considering? We are considering intervals from 0 to 1. Okay. So what will happen if you divide this interval in n equal parts? So let's divide this interval into an equal part. So if we divide the interval in an equal part, then the length of each subinterval must be 1 by n, right? Because the whole interval has length 1. So each subinterval will have length 1 by n. And this is the first point, 1 by n, 2 by n, 3 by n, and like this we will have up to here n minus 1 divided by n, and this the end point, this is n by n, right? So there are n many intervals, each of length 1 by n, so therefore the whole thing has length 1. So this is a partition. Okay, so this is your x naught, this is x1, x2, x3, like this is x1 minus 1, and this end point is xn. Okay, so what is the length of interval in this case? This is just xk minus xk minus 1. So this length of the interval is 1 by n, which we were saying that. Okay, so now you can see that this particular factor is just the length of your each subinterval in this partition. Okay, and further the norm of partition in this case, for this particular partition, okay, because each subinterval has constant length, then that means that length is also 1 by n. Okay, and the norm of partition goes to 0 if and only if n goes to infinity, right? So this limit is just in another form, it just says that the norm of partition, we are making it to go 0. Okay, what about the other part? Okay, so this is just the length of each subinterval. And what about this part? Okay, so this must be the values, functional values at some choice points, right? The choice of points which we were choosing inside the interval. Okay, so so in this case, these choice of intervals are also the same partition points. Okay, so this is our first point c1, this is our first point c2, c3, and like this. So the right hand points of this partition are our choice points. And if you consider this function f of x, which is just x times under root 1 plus x square, then you can see that what is choice point ck. Ck is just kth choice point, that means it must be k by n, right? The first point is 1 by n, second point is 2 by n, third point is 3 by n. So the kth point is k by n. And what is f of ck? F of ck is just k by n under root 1 plus k by n whole square, right? Which we can see, which appears at this point. Okay, that means the sum is just the integral of this function fx. Okay, now but what do we know about this function? We know that this function is again continuous and bounded, right? Fx is continuous and bounded, therefore, okay, so bounded in the interval 0 comma 1, and therefore f is integrable. And because the function is integrable, the limit of this series must be the integral, right? We were finding this limit. limit n going to infinity, which is same as the partition limit, the norm of partition going to 0. And we were finding the sum, where the sum is like this: k equal to 1 to n. Then this was the length of the interval. Then we have this from k by n into 1 plus k by n whole square. Now we realize that this integral is just this summation is the Riemann sum of a function which is integrable. Therefore, this limit must be the integral from 0 to 1 of that function fx dx. Okay, so this is our limit. Now, what is our function? It is x times 1 plus x square dx. Okay, so again, to calculate to evaluate this integral, we will put will change our variable x, right? Because we want to integrate this, and we don't know now some function whose derivative is this integral. So we'll use standard rule of substitution. So what we will do, let's assume that on the side note, let's write 1 plus x square to be some new variable t, and then if you differentiate, then 2x dx must be dt, right? So this what we'll do, we'll just divide by half and multiply by 2. So this 2x dx just will become dt, and we have to also find the lower and upper limit. So if x is 0, then t must be 1, and if x is equal to 1, then t must be 2. So this limit is same as the integral from 1 to 2, half outside, and then we have under root t dt. Now this integral we can evaluate easily, right? Why? Because if you consider this function capital F to be t to the power 3 by 2, right? So if you differentiate this function, then you can see that you will get 3 by 2 times t to the power half, which is just under root. Okay, but we have under root t, so that we can make by multiplying it some number, right? Multiply by 2 by 3. Then here also we have 2 by 3, and they will cancel with each other. Okay, so for this particular function, so derivative becomes t to the power half, which is just our function which we want. That means this is half of from integral 1 to 2 f prime t dt. Okay, and now again from the fundamental theorem of calculus or integral calculus, this is just f of 2 minus f of 1. This is our limit, which is half of, so what is f of 2? You can see that we have a 2 by 3 common, so let's write 2 by 3 outside, and then we have square root 2 minus 1. So this is 1 by 3 square root 2 minus 1. Okay, it's not 2 square root, it's power, we are taking the 2/3 power 3 by 2, right? Because the integral was, the capital F function was power 3 by 2. This is our final answer. The 1/3 of yes, the first option is correct, right? Here,
Right,
1/3 of 2 power 3 by 2 minus 1.
right.
So any questions?
We can proceed further.
Yeah, tell me.
Yes, you can proceed further. No question.
Okay, so let's move to the next problem. Okay, again we have to in this fourth problem we have to find this sum. Now we have to again realize this function as Riemann sum, right? This limit of this summation as Riemann sum of some function. So that function must involve cos, right? Because the cos is here, but what this function exactly is, so that we have to find out. So we'll just write this as limit n going to infinity and summation from k equal to 1 to n. And now we will write this keep 1 by n separately, because this will be our length of subintervals. So we are again going to choose a partition of our interval, whatever the interval is, into n equal parts, okay, n equal subintervals. And we have cos of, okay, so we have 2 pi also outside, 2 pi times cos of pi and k plus n divided by n, right? So let's see what do we get here, because this must be, because now this is our length of partition, right? Xi minus 1, and this everything must be our f of ck, where ck is the choice of points inside the subintervals of the partition. But here we have to find out what is our interval, right? So let's put limit k equal to 1. So if you put k equal to 1, then you are getting 1 plus n divided by n, right? Which is just 1 plus 1 by n. That means this is our first partition point, which was our C1. And if you put n equal k equal to n, then we are getting 2n divided by n, that is 2. That means this must be Cn. Okay. So now it shows that our partition point, these Ci's are like this. C1 is 1 plus 1 by n, C2 is 1 plus 2 by n, and like this. That means we must be dividing some interval 1 comma 2, right? Because the first interval starts from 1 plus 1 by n, then it ends at 2. Okay, so consider the partition p of the interval 1 comma 2. So what is our this partition? X naught equal to 1, then x1 equal to 1 plus 1 by n, x2 equal to 1 plus 2 by n, xn minus 1 equal to 1 plus n minus 1 by n, and then the last point is just 2, right? You can see that we have divided our interval 1 comma 2 into n equal parts. Okay, so what is the norm of p in this case? It is 1 by n. And again, this norm going to 0 if and only if n goes to infinity. And the choice points ck, we are choosing them as 1 plus k by n, again the right hand points. Okay, and therefore you can see that f of ck, it was coming out to be 2 pi of cos of pi 1 plus k by n, right? So this gives us that we must be taking a Riemann sum of this function fx, which is defined like this: 2 pi of cos pi x, right? Now we can see that again this function is continuous and bounded, therefore it must be integrable. On the interval 1 comma 2, and hence therefore f is integrable. And the limit which we were considering, partition norm of partition going to 0 or n goes to infinity, they are both same. So this was 2 pi over n cos pi k plus 1 by n, k starts from 1 to n. This limit, this must be the integral from 1 to 2 of our function 2 pi cos of pi x dx, right? Now how do we find this integral? Now notice this function capital F fx to be sine of pi x. Okay, and let's write a 2 also. So if you differentiate this function, then you will get, so this is pi x, sine of pi x. Okay, so using the chain rule you will get 2 pi cos pi x, right? That means that this limit, okay, so this limit must be integral 1 to 2 f prime x dx, and from the fundamental theorem of calculus, then this will be just f2 minus f of 1. And now if you calculate f2, so f2 must be 2 sine pi and minus 2 sine, okay, so this is 2 sine 2 pi, because f, this is f of 2, and then sine pi. Now we, you can see that sine pi is also 0 and sine 2 pi is also 0, so the integral is 0, right? So the first option is correct here, so this limit is 0. So any questions?
No, sir, no.
Okay, so let's move to the next problem. Okay, so this problem, so this is a different kind of problem, right? Because till now we were only finding the integrals which were given in terms of limits of Riemann sum, and we were finding limits basically via finding the integral. Now in this case, a function is given which is defined using this integral, right? So this is our function. So x is greater than 1 in this case, and then you have to find the derivative of this function y and take the square. Okay, so so basically we have to differentiate the integral, right? Because the function is given by this integral, so that means we have to differentiate the integral. But this limit, you can see this limit is also a function of x, right? That means this is a composite function, right? So why this is a composite function? Let me define something like this. What do we do? Okay, let's write f of x or z of x. Okay, so I'm writing z of x like this. Integral from 1 to x under root 3 plus t to power 3 by 2 dt. Okay, so this is one function. Let's write it z1, and z2 of x is just under root of x, right? So now you can see that if you compute this z1 of z2x, right, the composition, this composition turns out to be exactly equal to y of x. Okay, so that means the y function is just the composition of two functions. Okay, and if you want to differentiate the composite function, that means you have to apply the chain rule. Okay, so if you want to differentiate, if you want to find dy over dx, that is this composite function z1 z2x, so you have to apply the chain rule. So chain rule means you have to first differentiate this with respect to this z2, assuming that it is our independent variable. So just differentiate the everything with respect to z2, right? And then differentiate the z2 function. Okay, So what was z1? So we have to differentiate z1 first, right? Okay, so here we'll just recall this again, the fundamental theorem of calculus. So one theorem we have already recalled. So there are two parts. And we always assume the continuity of functions, right? So whenever we are taking some function, we will assume that a function is continuous. The first part just says that how do we differentiate an integral. So if you have this function a to x some gx dx, and this is your function, and you want to differentiate this function, so you are differentiating the integral. Okay, here we are assuming that g is continuous, so this function is continuous. Okay, so this is just g of x, right? Because we say that the integration is just the reverse of differentiation, right? And this theorem exactly says that it is true. So if you differentiate the integral, then you'll get back the original function. Similarly, if you integrate some derivative, so let's say you are integrating g prime of x dx, where we are again assuming that g prime x is continuous, then this is gb minus g of a. That means you are getting your function back, right? So if you are not integrating from a to b, let's say you are integrating from some t point, then you will get gt minus ga. So up to a constant, you get back your original function, right? So the second result we have already used when we were evaluating integrals or evaluating those limits, and this first part we will use now. Okay, so these are fundamental theorem of integral calculus. And you can see that we have to differentiate the function z1, and z1 is given by an integral. Okay, so what was z1? Let me recall once again. So z1 of x is just from 1 to x to outside, and then we have 3 plus t to the power 3 by 2 dt, right? Okay, so what is how do you differentiate this? You have to just find dz1 x dx, right? You want to differentiate this integral d by dx of this integral 1 to x 3 plus t to the power 3 by 2 dt. Now you can see that all these functions are continuous function, right? So this is a continuous function, and hence you can use the fundamental theorem of calculus, and you just get back your function, okay? Which is just 3 plus 2 times under root of 3 plus t. Okay, so we are changing the variable. Okay, so this here you have to write x because the function is given with respect to x. This is your derivative of your function z1. Okay, now what is the derivative of z2? What was z2? So z2 was just root x, right? So what is this derivative? Is this half times x to the power minus half, right? Or we can write it as 1 under root 1 divided by 2 times under root x. Okay, so let's write dy by dx. So how can we write dy by dx? It is as 2 times 3 plus x to the power 3 by 2 into 1 over 2 times root x, right? Now you can cancel this 2, and in the square root you can just write it 3 plus x to the power 3 by 2 divided by x, right? And therefore if you take the square both side, the square of this derivative, you will have just that 3x inverse plus x to the power minus half, right? Okay, so I think there is some mistake. Oh, okay. So we have to we were differentiating z1. So in this problem, we have to differentiate z1 with respect to z2x, right? So this was the problem. Okay, so for finding this dy by dx, you have to put z2 here in the place of x. Okay, so at this point, you have to write root x, right? Because according to the chain rule, we have to differentiate this function with respect to z2. So z2 was root x. So our root x was the variable, independent variable. This we were assuming that root x is constant and like independent variable, and we were differentiating this function z1 with respect to root x. Okay, so this means that z1 prime of z2x, right? You have to find z1 prime of z2x. So this you will get only when you put root x, 2 times 3 plus x to the power 3 by 4, right? You multiply by half. So here you have a 3 by 4, and therefore if you subtract 1 from 3 by 4, then you will get minus 1 by 4. So that's why the fourth answer is correct here. Okay, so any questions? I think there was some confusion with the chain rule.
No, I don't change it. I don't change it. Okay.
Okay, so let's move to next problem. So again, this problem based on this is the same kind of problem. You have to you can say that you have to find the value of your derivative at pi by 4. Okay, so the function is given. This is your function y, and then you have to differentiate it, and find the derivative, the value of the derivative at pi by 4. Okay, so for finding the derivative, you have to again apply the fundamental theorem of calculus. Let's write what is your function. This is yx to be cos square x pi by 2 dt divided by 1 over t square. Okay, and the domain of the function is also given. So what is the domain of this function? It's like lies from pi by 12 to pi by 2. And we have to find what is the derivative at pi by 4. Okay, so what do? We can write this function like this. We just change the upper and lower limit, and if you change them, then according to the properties of definite integral, you will have a minus sign outside. Okay, so this function, the same function, can be written like this, because now you can apply the fundamental theorem of integral calculus. Okay, but again, notice that here you have a cos square x. That will this is a composite function. So if you want to differentiate it, you have to apply the chain rule, right? So what is the derivative with respect to x? Apply the chain rule. So first you have to differentiate this integral with respect to cos square x, right? And if you differentiate this with respect to cos square x, then you will just get 1 over 1 minus cos to the power 4x. Okay, now you can differentiate the cos square x according to the chain rule. So if you differentiate cos square x, then you will get, according to chain rule, 2 times cos x, and then you have to differentiate cos x, and you'll get minus of sin x. So this minus minus sign, just make it plus sign, right? Okay, so this is our derivative. So 2 sin x cos x is just sin 2x, and Okay, so 1 minus cos power 4x. Can we simplify it? Okay, so let's write it like this only. Cos t power 4x. Okay, so what do we have to find? We have to find what is the derivative at pi by 4. So y prime of pi by 4. So at pi by 4, that means we have to just substitute the value pi by 4 in this thing. So this is just sine pi by 2, right? Divided by 1 minus cos x, which is just cos pi by 4 to fourth power. Okay. So what is sine pi by 2 is just 1, and what is cos pi by 4? Cos pi by 4 is just 1 by root 2. If you take the fourth power, then you will get 1 by 4. So 1 minus 1 by 4 is just 3 by 4. And if you take the square root, then you will get 2 by root 3. Right? So the second option is correct here. So any questions?
No, sir, it's okay.
Okay, so again, let's move to the next problem. Okay, so again in this problem we have to find this sum using the integral. So this is again we are back to the same kind of problems, and but in this here a lot of information is already given. Is given that you have a partition of the interval 1 comma 5, and then you are choosing this point ck inside this subintervals of your partition, and you have to find this limit of this sum. Okay, so you can now see that this is already this part is just the length of each subinterval, and this part is your f of ck, right? So what is f of ck here? Is just twice of ck minus 1 to the power minus half. So we are taking a 1 over square root thing, right? It means we must consider the function f of x, which is just square root of 2x minus 1, right? And we can see that this function is not defined when x becomes half, but we are inside the interval 1 comma 5. So inside this interval the function is defined, right? In this interval the f is continuous and bounded, and therefore f is integrable. Okay, and because f is integrable, that means the limit of this particular summation when your norm of partition goes to 0, and you have k from 0 to n, and you have f of ck into xk minus 1. This must be the integral from 1 to 5 of your fx dx. And now we know what is our function. 1 to 5, this is just 2x minus 1, right? So we have to find this integral. Okay, so again we'll just find out this integral using the rules of substitution. So let's substitute 2x minus 1 to be some t. Then you have 2 dx is dt. So right here 2 divided by half, and you can write this integral half of the 2 dx will just become du, and you have under root of u, right? And now you have to calculate the limits. So for limit you can see that if x is just 1, then your t must be, okay, we are our variable is t, right? So what is t? If x is 1, is 1, and when x is 5, then t is 9. So this is integral from 1 to 9. Okay, so for which function can we write it is derivative, right? So we have to see. You have to apply the fundamental theorem of calculus. So if I take this function capital Fx to be t to the power half. Okay, so what is its derivative? Its derivative is 1 over twice of under root t, right? So if I just remove this half from here, then I can write this interval as the derivative of our function dx, this function capital F, right? Because derivative is just 1 over 2 times under root t. Okay, and therefore from the fundamental theorem of the calculus, this is f of 9 minus f of 1, and that we can easily calculate now, right? Because under root, the function is just t to the power half, which is under root t. That means f of 9 is, it is 3 minus 1, that must be 2. Okay, so the answer is 2.
Okay, sir. Okay.
Okay, so let's move to the next problem. Again, you have a partition of this interval minus pi comma 0, and you have to find this limit. But again, you can see that this is again same kind of problem. So this is your length of the interval. This is must be f of ck. So you can easily guess that function must be cos of x by 2. Okay, so let's write this sum. Okay, so here you can see that the sum must be the integral from minus pi to 0 of your function cos x by 2 dx, right? Because we know that this is again continuous and bounded function, so it's integrable, and therefore the summation which written here, the whole summation is just this integral, right? Which we can write minus of the integral from 0 to pi cos x by 2 dx. Now let me consider this function fx to be 2 times sine x by 2, right? Because if you differentiate this, then you will have cos of x by 2, and therefore this sum just becomes minus from 0 to pi of the derivative of fx dx, right? And from the fundamental theorem of calculus, this just becomes minus of, okay, so let me write it directly. It will just become f of 0 minus f of y. So what is f of 0? So f was sine function, right? So f of 0 is 0 in this case. So, and we have f of pi, which is sine pi by 2, which is 1. So minus 2. Okay, so there is no minus option here. Okay, so that's the problem. It's minus pi to 0. And I have written 0 to pi. Okay. There was no need to write like this. Okay, so let it like this only, minus pi to 0. Minus pi to 0. So f of 0 and f of minus pi. So there is a minus sign inside, and that will make it plus sign. Therefore, the third option is correct here. Summation is, the limit is 2. Okay. So let's move to the next problem. So if you have any doubt, then you can ask, okay, in between. Now we'll consider this summation. Okay, so you can see that again this 1 by n, this summation you can write it as limit n going to infinity, summation k equal to 1 to n f of k by n into 1 by n, right? This must be the length of the your partition, xi minus xi minus 1, the length of your partition. And this is just f of k by n, that says that your chosen points inside the subintervals of the partition must be k by n. Okay, and because the length of the interval is 1 by n, that means your intervals have uniform length of 1 by n. That means you are dividing your intervals into n many equal parts. Okay, so if you put k equal to 1, then you can see that your c1 is just 1 by n, c2 is 2 by n, and like this, right? So that means the partition must look like this. Your first point must be 0, and second point is 1 by n. Then you have 2 by n, then n minus 1 by n, and then 1. Okay, so this is the partition, and the norm of this partition is 1 by n, okay, which goes to 0 as n tends to infinity. Okay, so you can see that this can be made into a Riemann sum. Limit n goes to infinity, summation f of k by n into 1 by n. It's just the Riemann sum where the norm of partition goes to 0, and f of ck and xi minus 1, where this length is 1 by n, ck is k by n, right? And what is given? It's given that fx is continuous, right? So we are always assuming continuity, because continuity always implies this function is integrable, and because function is integrable, that means this limit must be the integral from 0 to 1 of your function fx dx. Okay, so the fourth option is correct here. Okay, so let's move to the next problem. Okay, so you have to find this limit. So again, it's a summation, right? You can realize this, you can write this as the limit n going to infinity, summation f of k by n into 1 by n, right? So where what is k by n? Okay, so k by n is nothing, but what is fx? What is f? So f of x is sine pi by x, pi x, right? So this is our fx, and therefore f of k by n is sine pi k by n, right? So when you put k equal to 1, you get the first term sine pi n. When you put k equal to 2, then you get sine 2 pi over n. And if you put k equal to n, then you will get sine pi. So n will cancel. That means this summation must be the integral from 0 to 1, which we have already seen in the previous problem, that this was integral, right? From 0 to 1 fx dx. So this summation is just integral of sine pi x dx. Okay, so to find this sum, we have to calculate this integral. Okay, so which integral? 0 to 1 sine pi x dx. Okay, now let's take this function f of x, which is just 1 over pi cos pi x. Okay, so you can see that if you differentiate this function, then you will get a minus sign, so that will cancel, and then from chain rule pi is also cancel. We'll get just sine of pi x, okay, which is given here. That means this is 0 to 1 f prime x dx. Okay, so from the fundamental theorem of calculus, this can be just written like this: f of 1 minus f of 0. Okay, so this is our integral. And then what is f of 1? F of 1 is minus 1 over pi cos pi, and then you will have plus 1 over pi cos 0, right? The cos pi is minus 1, so minus 1 and minus 1, you will get plus 1, so 1 over pi plus, and cos 0 is 0, or cos 0 is 1, so you will have again 1 over pi. So the everything will give you 2 over pi. Okay, so third option is correct here. So any questions?
No, sir, it's okay. Proceed further.
Okay. Okay, so here we have this function which is given by integral and then we have to find the derivative dy by dx. Okay, so again we will use the fundamental theorem of calculus because we have to differentiate the integral, but then there is a x square, right? So that means we have to apply the chain rule. What is yx? Is integral 2 to x square 2 plus cos cube t under root dt, right? So let's differentiate this. So the derivative y prime of x must be, you have to differentiate the integral with respect to x square, right? First, then you will differentiate x square with respect to x because we are using chain rule. So if you differentiate the whole thing with respect to x square, so you have to apply the fundamental theorem of calculus. So you are differentiating the integrals, so you get your function back. So it is just 2 plus cos cube of x square, right? Square root into the derivative of x square, which is 2x. Okay, so I think this is the answer. Yes, so this is answer. The first option is correct here. Okay, so this is our next problem. Again, function is given and you have to find the derivative. So again, you have to apply the chain rule and the fundamental theorem of calculus. So what is yx? Integral the under root x to 1 integral 6 times the inverse of 3 plus t to the power 4 dt. Okay, so this we will write like this, from 1 to root x 6 3 plus t to the power 4 inverse dt. Okay, okay, again we can realize this y as a composite function, right? So let me write f of x as minus from 1 to x 6 times t to the power 4 inverse dt, and then gx as under root x, right? So now we can see that this yx is just f of under root x, right? Because f, if you put root x instead of this x, then you will get your function y. So it's a composite function. So root x is gx. Okay. So this is just composition. Now because we have to differentiate this y with respect to x, so we have to apply the chain rule, right? So what is derivative? This is just f prime of gx by chain rule into g prime of x, right? So f prime gx, right? First you have to calculate the what is derivative. What is f prime of x? That is just dy dx from okay. So there is a minus sign. So 1 to x, and then 6 times in the bracket you have a 3 plus t to the power 4 inverse dt. So if you differentiate this integral, then from the chain fundamental theorem of calculus, you will just get 6 times 3 plus x to the power 4 inverse, right? But we have to find f prime of gx. Okay, so you have to write f prime of gx. So f prime x is this. That means f prime gx must be uh, 6 divided by 3 plus x to the power 4. So in the place of x, you have to write gx. This is gx to the power 4. And then you have a derivative of x, gx. So what is derivative of gx? So gx was under root function, right? So if you differentiate the root function, you get 1 over 2 times root x. and therefore the derivative is just 6 times under root 2x, and in the bracket we have this 3 plus gx to the power 4, and gx what, under root x. So if you take the power 4, then you will get x square. Okay, so I think we are forgetting this minus sign. I'm forgetting this minus sign, so this minus sign, let's write it here. And then you can cancel out 6 by 2, and you have a minus 3, and then everything is just 3 under root x plus, okay, 2 plus half x to the power 5 by 2 inverse, or minus 3, 3 times x to the power half plus x times x power 5 by 2 inverse. Okay, so I think the previous version was correct. This okay, minus 3, taking root x outside like before, and then 3 plus x square, everything power minus 1. Okay, so the first option is correct here. So any questions?
No, sir, no.
Okay, so I think there are no questions, and I think I have solved all the problems of this problem set, all the 12 problems. And because I have already solved all the problems before time, so I think we can finish our live session at this point.
Yeah. Okay. Thank you, sir. Thank you.
Okay, so we'll just stop here, and we'll meet next week with again with a new set of problems. For that, for that, maybe that will be based on again definite integrals or some applications of definite integrals. We will see. Okay, so
Thank you. Bye.
okay, thanks for joining.
Bye, sir.
Yeah.